Have you ever wondered how our lives are shaped by complex engineering processes and colossal process plants that run day and night without active human control and intervention? From the foam in our sports shoes to the detergent that we use to wash clothes, or the deodorant that we spray after a good workout, and the gasoline that fuels our cars. All these are directly or indirectly produced in such process plants. These plants require a great deal of meticulous planning to ensure safe and timely completion. Setting up such a process plant is a complex task, involving not just hundreds of suppliers, consultants, and service providers from across the world, but multiple internal verticals and several stakeholders. With billions of dollars invested and sales orders in the pipeline, plant owners don't want to leave anything to chance. These challenges, along with recent technological and engineering developments, have resulted in a greater interest towards a concept called modularization of process plants. While modularization itself is possibly as ancient as the human civilization, modularization of large and complex process plants is a modern engineering technique used to break down a plant into vital working components and manufacture them individually at off-site locations. The individual units are customized or pre-assembled according to project requirements and are transported to the project site for quick installation and commissioning. Building such different blocks or modules of a process plant allows plant owners to save time, money, as well as human resources. Let us now see how this concept of modularization can be applied to a complex kerosene distillation plant. This plant is located in Kuwait City. The process designer is from Houston, Texas, and the modularization has been done in Pune, India. The most critical part of the modularization process is to develop a P&ID, which helps to easily distribute the equipment and components into self-contained skids. The development of a detailed 3D model follows. This is a kerosene purification plant using the distillation process. Due to height restrictions applicable at the site in Kuwait, the distillation tower had to be divided into two separate towers which operate in series. In line with design concepts of modular process plants, process and utility flows are divided into various skids. There are 4 process skids and 2 utility skids. The feed and the product kerosene streams are integrated in the transfer skid. The feed kerosene flows through a duplex particulate filter and 2 recuperative heat exchangers in series, where the hot product liquid preheats the liquid going to the lead distillation tower. The 2 product streams are further cooled by 2 water-cooled heat exchangers. The reboiler skid has a TEMA kettle-type reboiler, where the hot liquid enters from the bottom of the lead distillation tower and is heated and partially vaporized by circulating hot thermic fluid. This skid also contains the surge drum of the lag distillation tower. The OH liquid skid has 1 exchanger where feed kerosene is heated up by hot overhead vapor. The cool-down overhead vapor is further cooled in a water-cooled condenser where phase change occurs and liquid flows to the OH liquid receiver. Before hot liquid goes to the distillation tower, it is further heated in a thermic fluid exchanger. The pump skid is located below the ground. It comprises of 3 different API 610 hydrocarbon pumps. 1 for pumping product liquid from bottom of the reboiler, 1 for the overhead liquid, and the third one for reflux. The hot liquid from the OH liquid skid goes to the lead distillation tower as feed. The top overhead vapor then flows to the lag distillation tower. The entire residual heating process is done by Dowtherm A using a 2.2 megawatt electric heater, specialized circulating pumps, duplex hot oil filters, expansion and drain tanks. These components are housed in the hot oil skid. The cooling system with cooling tower and circulation pumps is mounted on the cooling tower skid. This kind of design engineering is a great example of interdisciplinary coordination involving 3D modeling, static equipment design, piping, electrical and instrumentation, automation and control. Is there any fundamental difference in the way a modular process plant is designed vis-à-vis a conventional plant?
We focus on small projects that can be modularized. So we do the upfront process engineering, we do the basic design, we do fabrication and modularization, and then we're able to ship that all over the world. And so we do distillation, we do gas plants, we do small refineries, we do small chemical plants.
When we talk modularization, means various units we try to put on skid and try to do the interconnection. Sometimes it can also happen that from skid A, outlet pipe moves over the skid B to go to the skid C. So the interaction is very important, especially piping, instrumentation, and the 3D modelers. And they have to put the things together as per the PNID.
Modularization requires reinforcement of structures and use of minimum ground space, which was ensured during engineering as well as fabrication stage.
Now, the design moves from the drawing board to the fabrication and assembly plant. The equipment, piping spools, and skid base frames are manufactured as per fabrication drawings, painted and assembled, along with bought-out components such as valves, pumps, and instruments. Cabling and tubing within the confines of the individual skids is challenging as well as time-consuming. Insulation of the skid equipment and piping is also quite difficult given the space constraints. How do we ensure that there is no deviation from project specifications, drawings, data sheets, manufacturing codes, and standards?
Since we are doing this for many years, all our processes such as engineering, fabrication, assembly, quality control, site supervision are aligned with the expectations of our end user.
We always focus on superior build quality, starting from incoming inspection of raw material to in-process inspection as per ASME codes and industry standards.
All this is in addition to meeting all the electrical and instrumentation requirements of hazardous area and all the applicable codes and standards for vessels and pipes.
Construction and design is as per ASME Section A Division 1 and measurement and tolerances as per API refinery standard and specification. During fabrication, we are carried out the in-process inspection and same thing will be verified by TUB, the third-party agency.
We understand that the key to success is standardization and modularization.
Welding is one of the key manufacturing processes employed in modular process plants. How does a company control and monitor weld quality?
As welding is our primary fabrication process, we are taking approximately 3,500 inch dia pipe spool joints along with LCM and CCM joints in this project. We are providing 100% full penetrated joint without back chipping to ensuring 100% RT. We are doing FCAW, GTAW, SMAW welding processes as per AS Section 9 and approved WPQ, PQR and WPS. We are always track the record of these weld joints through our welder performance list, and we always tracking to on a daily basis how much weld joints will be there.
Safety under normal as well as hazardous operating conditions is critical in any process plant. And this aspect is also not compromised in modularization.
Our customer wanted the plant to be very safe. So we put in extra safety devices. We made it much higher rated pressure. We made it extra safe.
Yeah, this entire package is in hazardous area zone 2, gas group 2A, 2B, T3. The design temperature is 330 degrees Celsius and the pressure is 15 bar gauge, which makes it a 300 class execution. Because of the very high temperature, all the transmitters used, which is the pressure transmitter and the flow transmitters, are with diaphragm seal. The pressure gauges are with siphon and diaphragm seal. As you can see that all the pipes, the vessels and the towers are insulated, and the insulation thickness is around 100 mm to 150 mm in various parts of the package.
Heating kerosene to a high temperature, then that kerosene becomes very hard to pump. So it's very hard to design the proper pumps for this process. So Alsana wants a very dependable process. So GPE and KLM, we took about 3 or 4 days and we optimized the design of the pumps so they would be safe and they would be economical and they would work as required.
To ensure that the entire system is stripped in case of a potential fire hazard, we have LEL detectors which are installed at areas which have possible leakage.
While modularization offers many benefits, it also poses its own set of challenges, such as packing, dispatch, and installation of relatively large and heavy skids.
So this entire package is divided into 6 skids, with the largest being 8 meters in length, 3.8 meters in width, and 5 meters in height. The dimensions of the package are based on the space limitations at client side and also the containerized cargo size limitation.
Having decades of commissioning experience, we understand setting up a process plant is a complex job involving multiple stakeholders. So we are offering comprehensive factory acceptance test at our facility with the help of third-party independent agencies, with engineering consultants and sometimes as our customer. During the FAT, we are doing electrical testing like PLC panel testing, that MCC panel, that PLC panels, and doing a pneumatic test with nitrogen. We are ensuring there is no leakage or any discrepancy on pipe spool line, instrumentation joints and valves. By saying this, we are always ensuring during the commissioning there will be not an issue occurring at client's place. So by this FAT, we always ensuring the package meets our expectation.
The skid hookup starts right from the minute we start planning the skids. The skids are designed in such a way that any interconnection should be done from skid to skid, and they're well planned and they start having easy assembly at site, and all the interconnecting piping has to be delivered accordingly in not fully weld conditions so that at site they are installed and then welded accordingly.
For the pipe spool, so we are marking an IPTP point with reference of PNID to ensure there will be a smooth commissioning activity at our client's place.
And I've been lucky. I've got to fly all around the world. I've went to Africa, I've went to India, I've went to the Philippines, I've went to Indonesia, I've went to Malaysia and Thailand to start up chemical plants. Okay, so I'm comfortable that we'll be able to commission this plant safely and reliably. So that level of experience in commissioning, and GPE will bring their programmers, they'll bring their mechanical engineers, their instrument engineers, and they will set the equipment up correctly so it can be started easily.
So before we dispatch our parts or spare list as well as our package to our customer, we have to ensure at our facility the packing should be done as per the guidelines. So what we are doing for the mandatory spare list, there will be a packing slip that is inserted to our wooden boxes, and as well as a pipe spool that is packed through HDP packing.
Another important aspect of modularization is the deployment of a robust project management and progress tracking system. A system which allows the plant owners to monitor project progress on a regular basis.
The crux of modularization is to shorten the overall project time. So the role of the project management is basically to see that they have got the contact with the customer, they can implement and reflect the customer's requirement in their drawings and the P&IDs, and see that the project is delivered on time.
Project management requires a detail-oriented approach where proper planning can help avoid any eventualities. Even something as unexpected and unprecedented as COVID-19.
India actually shut down all physical work for several months. We were already doing video Zooms and the different things like that because I'm based in the US and they're based there. So it didn't affect us from the engineering portion, but it did actually affect the shop portion because India actually shut down.
अपने कंपनी में 30 आदमी काम कर रहे थे। इसके लिए उनको लिए वहाँ से पहले हम लोग 4 व्हीलर करके दो आदमी को एक करके यहाँ पे कंपनी के गेट पे लेके आए। उसके बाद गेट पे लाने के बाद में पहला काम उनको हीटिंग मतलब टेम्परेचर चेक किया गया। उसके बाद सैनिटाइज़र हुआ। उसके बाद हम लोग कंपनी में इन किए। इन करने के बाद फिर हम लोग सोशल डिस्टेंसिंग का ध्यान में रखते हुए जो 2 मीटर का सोशल डिस्टेंसिंग था वो हिसाब से हम लोग फॉलो करके काम को किए। और फिर उसके बाद छोड़ने के टाइम में भी उनका मतलब टेम्परेचर चेक किया गया और सैनिटाइज़र करके दो आदमी के करके घर पे छोड़ा गया। उसके लिए हम लोग जैसे आप आदमी को लेके जब ये आ रहे थे तभी हर दिन प्लानिंग करके कौन सा काम आगे करके निकालना है वो हिसाब से डेली के डेली प्लानिंग करते हुए भी हम लोग काम को फॉलो करके काम को आगे निकाल के लिए है। अलग अलग टीम जैसे आ गए अपने पास इंसुलेशन केबलिंग टीविंग के लिए 3 टीम है अपने पास। उसके लिए हम लोग अलग अलग स्किड पे डिवाइड करके उनसे सोशल डिस्टेंसिंग का ध्यान में रखते हुए ही उनसे काम निकाल के ले लिए।
As the world moves towards increased automation, modularization is on course to becoming a crucial aspect in the success of complex plant engineering and manufacturing processes.
Well, in the oil and gas industry, before that what happened in the year 2018, almost 500 million population of the world is connected to World Wide Web. So because of that, there are a lot of modern technology has emerged like cryptocurrency, Internet of Things. Then you can also say about artificial intelligence. Because of these forces, a faster response was demanded by the market. So that similar trend has also emerged in oil and gas sector.
I personally feel that down the line, next 5-10 years, a lot of modularization will start, especially the small and medium plants. Large plants partly can be modularized, partly has to be on site itself.
We believe that small chemical plants, small refineries, small natural gas plants, glycol dew point plants, amine treatment plants. So there's a wide range of chemical plants that can be modularized.
So while technology might have taken a rover to Mars or heralded an era where machines talk to each other as well as to humans, nothing is possible without human imagination and collaborative effort.
We follow the culture of inclusiveness, where be it a draftsman, an engineer, a manager or a director, everyone has their say in the process improvement and bringing their unique ideas to the table.
Modularization, like any other human endeavor, depends on our ability to appreciate and manage diverse teams and skill sets.
Gas processing equipment is a trusted name in engineering and supply of process units, plants, skid packages, and equipment. KLM, based in the USA and Southeast Asia, mostly Malaysia since 1995, is a technical consultancy group providing specialized services and equipment to improve process plant operability, efficiency, profitability, and safety. GPE's core businesses: basic engineering design packages, detailed engineering design packages, equipment fabrication, modular construction, unit commissioning. KLM's core plant businesses: process plant training, engineering design guidelines. We have 120 engineering design guidelines on most every piece of equipment in a chemical plant